For green chemistry, there are 12 principles of green chemistry that talking about how you can manage the chemicals and the reactions in order to produce a kind of chemical or kind of product in industrial scale or in your laboratory. 12 principles of green chemistry can be summarized into some kind of very important topics around here. So starting with a kind of chemical reactions. So for example, this is the process of producing acetophenone, okay, from this kind of alcohol. So actually, in order to oxidize the alcohol to be ketone, to be carbonyl like this, there are so many ways. Okay? And one of the things, very conventional way to produce the acetophenone from this is a oxidation with chromic oxide. Okay? The chromic oxide, with the presence of sulfuric acid, you can then oxidize your alcohol directly from the secondary alcohol to the ketone like this. Okay? So this is the conventional one, which is very simple, but anyway, it includes some kind of chemicals that are quite toxic, and you need the waste management in order to get rid of the byproduct from the reaction. So the green chemistry is talking about how you can manage the thing into a safer way for your environment. And as I said, there are several categories here. Let's talking about the first one, waste management. Because in this reaction, not only your ketone that is produced, but also there are kind of byproducts. So as you can see, you're starting from the chromic oxide here, which is chromium +6 oxidation number. So after reaction here, chromium is reduced to be chromium 3 ion. Okay? And the chromium 3 ion is kind of metals. Okay? And if this kind of metal released into environment, it is toxic to aquatic medium. Okay? So what you have to do is get rid of that chromium 3 ions. But if you change the process from the conventional method here to be some kind of greener version, so instead of using chromium oxide, we're going to use oxygen gas instead. But actually, oxygen gas cannot directly oxidize your alcohol to ketone very easy. So what you have to do is kind of development of the catalyst. Okay? If you have a proper catalyst, you can manage to make this happen. Right? So in chemistry world, what is the duty of the chemist is kind of develop a new kind of catalyst in order to make this thing happen. Okay? So the profitable things that you've seen from this reaction directly here is instead of using hazardous chemical like chromic oxide and producing waste like chromium 3 ion, you reduce that. Right? So the waste management is easier. Right? So instead of having chromium 3 ion and you have to treat your water, the aqueous waste from the reactions, you don't have to now if you have a kind of safer chemical pathway. Okay? Not only the waste management, but also the atomic economy here. Atomic economy means that if you're starting from a kind of molecules producing your products, okay? So sometimes you have to modify the molecules by different kind of methods like this. In the input, right, you put this one in the process. You put chromium oxide, you put sulfuric acid, but what you need is actually only this. Okay? So you lost so many things. Right? This is atomic economy. Right? But this one, you're starting from this, and also the catalyst. Right? But the catalyst, normally we use only few percent, like 5% or 10%. So that means the input, the weight of atoms or the weight of your starting materials in the input is quite similar to the weight of your products produced from the reaction. You lost less than the conventional method. Okay? Or if we talk about some kind of similar reaction to produce this one, you can also make the reactions from this kind of, for example, if you have this, okay, the alkene. You can also oxidize this one by ozonolysis or things like that. But then you lost CH2 part. Here is the actual product from this cleavage. Okay. So in order to, so if we talk about the atom economy, you lost this carbon. Okay, you lost 2 hydrogen, right? The formaldehyde is released into the atmosphere because it's the gas. Okay, so you lost some part of the compound. So this is not atom economy, right? Because you lost atom. The atom economy means that if you're starting from 100 atoms of the starting materials, then you produce nearly of the 100 atom in the products. Is atom economy. But if you use huge molecules to produce a very small atom, small molecules, so you lost so many atoms in the system, in the reactions. This is not atom economy. So to preserve the atoms, preserve the chemicals, you have to use the process that you lost less atoms, right? Because if you lost many atoms, if you lost big part of the molecules, that means you produce more waste. Okay. Hazardous chemicals using in the reactions is very important because it's not only the waste management is problematic, but it also causes some kind of toxic to your body as well, and also to the environment. So hazardous chemical or the kind of chemicals that you use in the reactions, you have to select kind of safer chemicals. Okay, and this also includes the solvent system. Okay, so if you use the reactions in kind of organic solvent or halogenated solvent, the waste treatment after reaction is very important because you release organic solvent into the environment. And if the organic solvent you're using is the halogenated one, like dichloromethane, chloroform, things like that, the treatment of the waste with halogenated waste like this is more expensive. Okay, you have to invest the money into the industrial. What else? Energy efficient as well. So normally the oxidation process like this, you need some kind of heat. Okay, but if you have a proper catalyst that can speed up the reaction efficiently, so you don't have to use heat much. Okay, so heating the reaction up requires energy, right? Requires fossil fuels, or maybe requires the electricity, things like that. Okay, so if you reduce the energy by like instead of using very high temperature, you use pressure instead. Okay, that you can reduce the energy required, because normally heating up things and pressurize things, you invest different amount of money actually. Next one is the renewable raw materials. So in this case, as you can see, the raw material using here is the same actually, the starting material, but also you have to buy kind of formic acid and sulfuric acid. But in this reaction, you use oxygen gas in the air. So this is renewable raw material. Also, if you have to heat up the system, okay, using petroleum oil is not a renewable one, right? So sometimes the renewable materials, you have to think about the renewable energy sources in the reaction as well. And yeah, the last topic is like catalyst. So if you can use very efficient catalyst, you reduce all of the things up here, right? So it's a kind of, the green chemistry is the kind of how you can manage the reactions to be safer for your health, for the environment and everything.